Welcome to Maths for You channel. Another past question on binomial expansion. The coefficients of x and x to the power of 4 of the binomial expansion of x squared plus 3k divided by x to the power of 8 are equal. The coefficient of x and x to the power of 4 are equal. Find the value of the constant k. Let me write that actual function x squared plus 3k divided by x to the power of 8. That is the power of 8, and second order function is inside the bracket. What we have been given, the coefficient of x and x to the power of 4 are equal. To do this question, in this binomial expansion, we could find the common term because of to the power of 8. There are 9 terms in that, so it's time consuming. You write the whole lot, so you can find the common term, which is our term between 0 to 8. Let's write it down. UR is the common term, any one of those terms in that series expansion. 8CR, R term, x to the power of 2 to the power of 8 minus r times 3k divided by x to the power of r. Just a normal binomial expansion. That's just a normal property of binomial expansion. So it's for the common term of r. The r could be anything between 1 to 8, or 0 to 8, but 0 it's the x to the power of 0 anywhere, so we don't need that. Yeah, sure. UR equal 8CR times x to the power 16. So 2 times 8 minus r is 16 minus 2r times 3k to the power r. Then x to the power, if I could take that to the denominator, the power become negative, so x to the power minus r. If you could simplify it, 8CR times x to the power of 16 minus 2r, we have a minus r, so minus r, times 3k to the power r. If I could tidy up a bit, 8CR times 3k to the power r times x to the power 16 minus 3r. So this is the power. X to the power is 16 minus 3r. What we've been given in that question, the coefficient of x to the power 1, coefficient of x to the power 4. Let's say the coefficient of x to the power 1. So for that, the 16 minus 3r should be 1. So for x to the power of 1, 16 minus 3r equal 1. From that, you get 3r equal 15, r equal 5. So r equal 5, the fifth term, or sixth term rather, is the power of that is x to the power 1. So the coefficient, the coefficient of that, 8C5, 3k to the power 5. That's the coefficient. Then we need to look at x to the power of 4 coefficient. So x to the power of 4, so for that x to the power of 4, 16 minus 3r again, 16 minus 3r equal 4. So either one of them. So from that, 3r equal 12, r equal 4. So it's the fifth term, r equal 4. The coefficient of x to the power of 4 equal 8C4, 3k to the power 4. We know that the coefficient of x to the power 1 equal the coefficient of x to the power 4. Therefore, if you could equate the coefficients of x to the power 1 and 4, x to the power 1, 8C5, 3k to the power 5 equal 8C4, 3k to the power 4. We can cancel out 3k to the power 4 on this left hand side, 3k to the power 5. So 5 minus 4 is 1. Now on the left hand side, we could sort of write it, expand it, 8 factorial 8 or 8 factorial divided by 5 factorial times 3 factorial, and then 3k equal. The right hand side, 8 factorial divided by 4 factorial times 4 factorial. 8 factorial on the both sides of the numerator can be cancelled out. So 1, 3k, and the denominator of left hand side, instead of 5 factorial, I just wrote it as 5 times 4 factorial, and again 3 factorial as it is. And the right hand side denominator, is 4 factorial, keep it that way. And instead of 4 factorial, I just wrote it as 4 times 3 factorial. Now, so we can cancel out 8 factorial on the top, and the bottom 4 factorial, and 3 factorial. So what we left with, 3k divided by 5 on the left hand side, 1 divided by 4 on the right hand side. So 3k over 5 equal 1 over 4. Therefore, k equal 5 over 12. That is what we have been asked to find, the value of k. Thank you. Please subscribe the channel and share the contents with other students, other beneficiaries. Thank you.